In the 19th century, textile mills began installing perforated pipe systems, which could manually be flooded with water to put out a fire before it got out of hand. Then, in 1872, the first automatic system was created and was perfected 2 years later by the owner of a piano factory named H.S. Parmalee. The system used heat-activated material that released the tension on a spring, allowing water to flow through the pipe. And modern systems dating to 1889 pretty much do the same thing, but today we're using a piece of glass to hold back the water. Because of this heat-activated bead, only sprinklers subjected to hundreds of degrees will spray water, not every sprinkler everywhere. If you look at a fire sprinkler today, you'll likely see a tiny glass bead filled with liquid or a color-coded piece of metal called a fusible link. The beads are easiest to spot, and the color of that bead tells you how hot the ceiling can get before the sprinkler will go off. These systems work with simple physics. Inside the bead is a glycerin-based liquid, sugar alcohol, which expands when heated to a specific temperature. That expansion breaks the glass, allowing what's inside of the pipe to come out. A hotel or a home goes up in flames more quickly and at lower temperatures than, say, a factory. So different buildings will have different classifications. Red beads break at the lowest temperature of 135 to 170 degrees, so they're the most common. Intermediate levels are yellow or green, and they break at 175 to 225, and it's a range. The highest levels are for warehouses and factories. They have black beads, which break at 650 Fahrenheit.